Okay, this week we're going to start pulling everything you've learned into some circulations. We're going to start with the global circulation. You think about it, the global circulation, basically, if you looked at it, all the heating that would go on at the equator, there would be low pressure. All the cold air, think of denser air. At the North Pole, there would be high pressure. But the Earth rotates. So instead of just one nice, simple circulation cell, we actually have three of them. At between 30 and degrees north or whatever, you have the rising air over the equator and sinking about 30 degrees north. Then you have another area of rising air up towards 60 degrees north. And finally, the sinking air up at the pole. So let's take just a quick peek at that image. If you looked at today's weather map, 30 degrees north should be relatively high pressure. And if you go out and zoom out here a little bit more, high pressure out here, high pressure off the East Coast. And you all that live in the tropics know that you have a lot of high pressure. And that's the doldrums actually right in that area. Not much wind, a little bit south of 30. These highs tend to be there all the time. Towards 60 degrees north, look at all the lows. 1, 2, 3. Another one up here, 4. So that's just an example of how the actual global atmosphere looks in comparison to general terms. I mean, yeah, there are, like we see here, high pressure, high pressure, high pressure, low, high, low, high. But so there's basically a storm track up near 60 degrees north. And there's basically high pressure around 30 degrees north. And another storm track down by the intertropical convergence zone. So really, the general circulation of the Earth actually is playing out in what you're seeing right here. So with that, there are monsoons that form. Maybe these highs move a little bit further north in the winter, in the summertime. So if they move that little bit, maybe the winds become more monsoonal over particularly the Indian Ocean, for example, and you wind up getting winds out of the southwest in there into India, and you wind up with plenty of rain. Believe it or not, there's actually a monsoon in the U.S., and it's called the North American monsoon. It's over the southwest part of the United States. Actually high pressure aloft. With that, at the low levels, then you see there's wind coming in on these vectors out of the Gulf of Mexico and up into New Mexico, Mexico, Texas, Arizona. And this develops and becomes almost a permanent feature in the summertime. So you can actually see it. And it begins with the heating in the Sierra Madre Mountains. That heating causes low pressure at the surface, but it's very warm. So it causes high pressure aloft. So you wind up getting pretty much a permanent circulation of low at the surface, high aloft. You wind up pulling moisture in. There's subsidence to the east and west of it. I mean, you wind up with rising motion. And what happens, you can actually watch this. The circulation will develop to the south of the area, and you can actually see thunderstorms developing, southern part of there, gradually moving northward, and they gradually develop over lots of Arizona and New Mexico area. So that's another example of a monsoon that we get. Again, part of the global circulation. These are big circulations. They cover tens of thousands of square miles. So I want to fly through a little bit here because we talk about the jet stream and it sinks down in the wintertime. There's actually two jets. There's a subtropic jet and there's a frontal polar jet. You might be used to hearing about the polar jet because that's one that's really tied into a lot of the cold air that comes down to the U.S. and all. But there is a subtropical jet, and it goes a little bit further south. And when they two merge, you can really get some tremendous storms happen. And you can even see a split sometimes in very strong winds coming into the west coast of the U.S. So you can actually see, remember, the atmosphere is warmer to the south, so the tropopause is higher. So the subtropical jet tends to be higher up in the atmosphere, more like around 200 millibars, 250. And this is more like 250 to 300 millibars. So you can see there's a difference in where these jets are and where you go to the stratosphere. But they're right on the tropopause. Climatology, just basically looking at the global circulations. So now we're going to deal with fronts and extratropical cyclones. Basically, they come in all shapes, pretty much. But a lot of them occur across the U.S. in the mid-latitudes. You don't get fronts in Curacao or Trinidad Tobago. May get one in the wintertime that might get down there very weakly off the Florida coast. But they're just not happening down there. So what are these fronts? They're air masses. Let's go back to this map here a minute and zoom in. And if you were to zoom in up north here, high pressure up here. And an air mass is basically just a body of air that has uniform conditions. Continental polar air masses develop right up here in Canada or Siberia or across the poles, and they'll move south into the U.S. However, then you have the maritime tropical air masses that develop down over Curacao, Trinidad Tobago. They warm over the tropical oceans. They're kind of moist. They're very warm. You can get further south in the United States. Maybe high pressure develops down here in the desert southwest. Could be a continental tropical, where you get the heating. It gets very warm, but you also have very dry air. There's maritime polar. These air masses tend to develop out over the Pacific or the North Atlantic. There's big high pressures that develop there in the wintertime. So these are just some examples of air masses. And where there's separation of air masses, there's a front. For example, here's a cold front right now. Temperatures on one side are in the 60s and 50s. On the other side, ahead of the warm front, are in the 70s, even some almost in the 80s down here. So there's a definite boundary, a shift in temperatures. One separates probably a continental polar air mass, the other one's more maritime tropical air mass. And where these boundaries come together, sometimes low pressures develop, and they're the extratropical cyclones we're going to talk about now. So we're going to develop one this week, and I want you to kind of watch this loop. And we're going to focus in towards the latter part of the week. So I want to start a loop here, and we'll talk about it as it's moving along. So you can see way out in the future. Let's go back to the first slide here, the very beginning of this, and start it. We're not getting back to the first slide, am I? Oh well, let's see if I can get back there. Interesting. All right, well, we'll try this a little bit minute here. Because I had it earlier, and I will apologize for that. So Z. All right, now we're moving. What you see here, there's no real good, strong, low pressure system. One developing out here. That's along a cold front right here. And there's another weak low down in Texas with that. That cold front is moving southeast. See, there's high pressure building in behind it. Look at the 0-degree isotherm here, which is at 850 millibars or 5,000 feet, coming down behind it. So it's packing right along that front. There's a very strong temperature gradient. And remember, fronts are three-dimensional. So you actually, if you were flying, you might stay in the warm air a little bit further west and then move into the colder air there, further to the east. Notice this low developing right there. So I'm going to stop this right here. And I want to look at this at the same time. Now, if we can go this way this time. Nope, it did not. We're going to move along here a minute. But you can see here, this is the jet stream. And these are jet streaks, really strong air. And this is plunging in here, and it's actually coming up the right-hand side, and will develop a new jet streak on this side. This momentum, this energy coming from this jet streak is going to transfer to the right with time. And you can actually see this taking place as this jet is getting stronger and stronger, and there's another one even forming here. And we were looking out in the future here a little bit. And right about there is where we had the other low. Low was right here. Well, divergence on jet streaks occurs in the left front quadrant or the right rear. Well, this is right rear, right there. So the first reason this low is forming, in order to get an extratropical cyclone, you need divergence aloft. Well, it has that now. You need temperature gradient. Well, guess what? There's fairly decent temperature gradient, and we're fairly close to the Gulf Stream, so there's always a temperature gradient there. So we have two of the ingredients you need to get extratropical cyclones, and that's what is going on here. That extratropical cyclone will develop, a lot of it based on how much temperature gradient there is and how much divergence aloft there is. If the divergence aloft gets very strong, then the low will deepen quickly, and you'll get a much stronger low. If the temperature gradient is very, very strong, and sometimes in the wintertime, you can go from plus 15 Celsius out over the Gulf of Mexico, on the Gulf Stream, to minus 20 here in a very short distance, 35, 40 degrees of temperature contrast right there. Right now, there's only probably about 9 or 10 degrees of temperature contrast in a pretty short distance. So, not the same. That's why this low isn't going to develop and become as strong with time. But it does develop. It pushes up through New England there and up, looks much better up here. And it has a much stronger temperature gradient now. You can actually see temperatures from minus 9 there. Looks like about plus 6, plus 9 there. So about 18, 20 degrees of temperature difference. Probably better divergence. And it's getting closer to 6 degrees north, where these lows tend to get stronger. One final thing I wanted to just show you with all this. Here's a low developing right now southwest of Alaska. You can see on the temperature, on the cloud pattern, cloud streak right here coming up, which is probably along a cold front. Here's your low back here. Actually, maybe a little bit of dry air in right between the two. This low is just developing right now. So you can look at satellite and pick out lows. Sometimes you can see where they are based on clouds developing out ahead of them and where they're beginning to develop. Sometimes you actually see convection develop with lows before the actual low begins. And other times it's more the low develops and then the convection starts taking place, particularly off the east coast of the U.S. But by looking at these satellite pictures, you can really get a depiction of what's going on. And it's a quick look just to see if the models, what you're hearing in the forecast, are making any sense to you. If this is looking totally different than what you're hearing from the forecast, well, then maybe you need to be adjusting your forecast. So that's pretty much what I wanted to talk about here. Let me know if you have any questions.